Okay, today is March 16th, and I'm back out here going to work on this, try to get the ring and pinion gear set, get that all buttoned up today. So just a recap from yesterday, what I ended up doing to get zero in play was a total of 65 thousandths, and if I remember correctly, I've got 30 of that on this side, 35 on this side, and I've got the pinion installed. Not with all of the new stuff, of course. I'm using setup bearings and so forth. And I measured with the dial indicator. I've got 6 thousandths of backlash, which is what they're calling for at G2, that this ring and pinion seem to work best at. So I've got that 6 thousandths there. I've got zero in play. I did put my caps on just because, you know, when I flip this over and back and forth, I don't want that thing to fall out of there. So, okay. Borrowing an idea from another YouTuber out there that rebuilt his Dana 30, I believe his name is Mike, thought he had an excellent idea by just developing this spreadsheet here. And what this is for is I'm trying to achieve zero end play. I think I've already done that, but I went ahead and filled in all of the combinations of shims I could use to achieve that. So what I've done is I've created 20 sets across here of different combinations. I measured each one of the shims that I have available to me, which is what's represented there, and the quantity of each that I have, which is represented there. And I repeated that same thing for the driver's side, because I don't know which shims I'm going to use on the passenger side and on the driver's side ultimately until I see the contact pattern of the teeth. But I do know it's 65. So what I have here what I did is I started at 10 thousandths, went to 11, 12, 13, 14, and then down here, what would I need in addition to, say, the 10? Well, I would need 55 added to that, gives me the target of 65 thousandths with a delta of 0 in this case, meaning it worked out perfectly. There was no change needed or anything like that, no difference. So what I had was, starting with the 1 10,000ths, I had to have two 20s and a 15, giving me 55 plus 10, that's 65. Did the same thing for all of the sets. Here I have to have 11, so I had a 9 and a 2. And then down here I have two 20s, 1 15, and 1 9, giving me a total of 65 again. So I did that for all those sets. The only one that I had a delta of 1 on was set number 3. I wasn't able to achieve the 65 as a goal. I had a 50, what is this, 40, 52, yeah, 52, and then the 12. That only gives me 64. So I'm minus 1 thousandths of a shim thickness that I really need. So this just shows me at a quick glance, you know, what combinations I can use. And again, depending on where the ring and pinion are in relationship to one another, as I looked at the gear tooth pattern, which I'm getting ready to do here shortly, I can know where I would need to possibly move things around by using this chart. Now, something I've talked about already that I'm going to just discuss briefly again is that MHD I was referring to is called the master housing dimension. And that is the distance between the axle center line and the back of the pinion head, not the top face, but the back. So this equals the pinion head thickness plus the pinion depth from the axle center line. And that's what that 3.625 on that G2 pinion gear was representing. So I measured the new pinion head thickness to be 1.355. The old one was 1.365, giving me a delta of 10 thousandths. And so that means whatever the thickness of the shims and oil baffle were in the original setup, I need to add 10 thousandths of shim to that to get the same measurement as the factory pinion depth. This will be my starting point to check the gear teeth contact pattern. And so I've got that set up already in the housing. And then another thing, Spicer says to add 15 thousandths of an inch of thickness to the zero end play to get bearing preload. However, this guy on YouTube, his call tag or whatever is Metal Shaper. I guess he does axles all the time. He says that he uses 5 thousandths, and I think that might be who Mike was referring to as well. I'm probably going to go. I might go somewhere around 10. I'll split the difference between them. So I'll be going for about 10 thousandths of additional shim to the zero end play, or thereabouts. So, all right, here we go. Okay, so that's the first go around. This is the little gear anatomy here. This top portion right here is called the land or the face, and at the bottom of the gear tooth is called the root. What's in between there is on the top side of the gear flank here is the what's called the addendum, and then the bottom side is the dedendum. More importantly, in this case here, what we're looking for is to have a pattern that is centered between the land and the root, so it's not coming off the gear tooth, but it's also not buried into the root down there, which would create all kinds of noise. But ideally, we also want the contact pattern to be centered on the tooth this way. So if you look at that, it's a little too close to the what's called the toe, which is down here. This is the heel, that's the toe. So it's a little bit too close to the toe. It's not running off the gear tooth in any place, but it looks like it might be a little bit too deep into the root. And now that's the drive side. On the coast side, it looks like it might be a little bit too far into the root there. So I think what I'm going to do, based on some diagrams I've looked at and so forth, I'm going to remove 5 thousandths from the pinion and get it further away from the ring gear, which will change my backlash, so I'll have to reset that probably. But that should move the this pattern right here more towards the heel, and at the same time getting it out of the root of the gear tooth on the back side, on the coast side. All right, I got those painted up. I actually painted up 4 of them this time. And now what I'm going to do is I'm going to spin the pinion while applying a load with my other hand, simulating a load, that is.
Go back the other way. One more time. Okay, let's take a look at that.
Okay, I'm going to go with that. Talked to a guy at Auburn Gear who is the gear tech guy when I was setting up my AMC 20 with the Auburn Gear grip and lock. He had helped me a little bit on the gear tooth contact pattern optimization on that one as well. So I sent him pictures of what I had here first time, or the first set of pictures, and it was his recommendation that I remove 5 thousandths from the pinion to get it further away from the center line. So I did that, and remarkably, it made quite a bit of difference. And so it's his opinion, and I'm going to go with it because the AMC 20 is doing fine. I've probably got, I don't know, 5,000 miles on it since I did it about 5 months ago. And it's doing good. There's no noise or anything like that. He said that because there's, and I agree, because the marking here is between the land and the root, and it's almost identical to that on the coast side. That's about as good as you're going to get. If I take any more away, then it's going to it's not going to have those in their optimal position, or close to being perfectly centered. So I'm going to roll with that. I don't expect to hear any noise or anything out of it. So now I'm just going to pull everything out of there, get the final races and bearings in, and also he recommended on the preload, while the Spicer manual does say 15 thousandths, I think that seems high. He agreed. He said he would stick to the, in his opinion, 6 to 8. I think I'm going to go with either 8 or 10, whatever combination I have. 8 thousandths is what I did on the AMC 20, so I think I'm just going to try to go for that on this as well, for bearing preload on the carrier. Right. Okay, I'm getting ready to press on the final bearings, the new bearings. And so on the ring gear side with zero in play, I had 35 thousandths. On the non-ring gear side, I had 30 thousandths, giving a total of 65. The Spicer manual says to add 15 thousandths of bearing preload. I think that's a little bit high. Talked to the Auburn gear guy, and he suggests 6 to 8 thousandths of preload, just like the AMC 20. And the other guy on YouTube, I forgot his name, that does axles all the time, does 5 thousandths preload. So I'm going to add 4 thousandths to each side. So on the ring gear side, that's going to put that at 39 thousandths, and that's what I have right here. I've got 2 12s and a 15, giving me 39. So I'm going to set those on there. I'm going to get my bearing and press that on. I found a little bit better driver for that, even though the socket I was using did cover most of the inside race of this bearing. This thing for my ball joint removal tool kit is actually better. So I'm going to redo this, or make sure it's all the way seated, I should say. Okay, on the non-ring gear side, it was 30 thousandths, so I would need 4 more thousandths. I don't have a 4 thousandths shim. I do have a 5 thousandths, so I'm going to go with that. So it's giving a total of 35 on this side, 39 on that side. So it gives me a total preload of 9 thousandths, and I'm comfortable with that. So there we go. Okay, I got the shims installed on there, so I have 39 thousandths on this side, 35 thousandths on this side. That accounts for 9 thousandths of preload. And I've got the thing seated in there. I double checked and made sure that my backlash is still 6 thousandths, and it is. So, of course I did it with a dial indicator, so I know it's 6 thousandths. So this is done. I'm gonna get it out of there, get the pinion out of there, and get the final races and bearings installed. Okay, so I've got my oil baffle in there and my shims, and this is gonna be my final race that I have to seat down in there. So let me go grab a tool to do that. Okay, I've got this tool right here. This is a 72 millimeter driver, and I'm going to put it down in there on top of that race and drive that thing down in there. There we go.
Okay, you can hear how it reached bottom there. So that's definitely in there.
Okay, now I got to install my tail, the pinion tail bearing race. So I gotta get that taken care of. Okay, I got that seated in there. You could tell when it was seated the way it feels and the way it sounds. So that's definitely all the way down in there. So the next step is to stick the pinion back up through there, get the pinion bearing preload shims in there, and then the bearing itself. And I'm not going to do a full assembly yet because I still want to see what things are going to look like and feel like once I have, I believe, probably 20 inch-pounds of rotational torque on this, and see what we have. Okay, now the original shim pack for the pinion bearing preload I measured with 65 thousandths. So these are the new shims here, and I've got a total of 65 thousandths as well. One thing I noticed is these are a smaller radius overall than the other ones were, but that's what G2 sent, so I'm going to put those in there.
Give it the lube on the steering here.
Okay, this is a copy of the original service manual, and the pinion nut calls for 210 foot-pounds of torque, after which I can check the bearing preload, which should be around 15 to 20 inch-pounds. This will conclude part one of the differential assembly.